All right, class, welcome to section 1.2, the domain and range of a function. So we already talked a little bit about it last section, that the domain is the set of all possible x values. So all the input values, which we call, where x we call the input values, right? And the set of all possible x values is called the domain. However, it's the set really of all possible x values that can be plugged into a function in order to produce real number answers. So the reason why I'm saying this is that sometimes for certain expressions, we cannot evaluate them for all possible x values. So we're going to see in a minute what those type of expressions are. Now the range is the set of all possible y values, all outputs. Here, let me even write that down. That are produced by the x values in the domain. So remember, you cannot produce something that's not a real number. Now for most functions, the domain and the range is the set of all real numbers, which instead of writing so much, so we talked about all real numbers or real numbers in the first section. That's how we started our discussion on. So we don't want to write all real numbers or so. So the notation for it is just an R with the double. So instead, don't just write R, but when we type this on paper, we put a double line on this R thingy here. All right. So here it is. Let's just practice on one really quick example. What would be the domain and the range of this set of ordered pairs? So again, the domain is all the x's. And the range is all the y values. And you do not have to put them in order. So 5, I already have 5. I don't need to write it again. 90 and 4. So these are all the possible y's. And you don't need to write 5 3 times because you already have it as a possible y value. Yes. Okay, now I mentioned that sometimes we can't plug in anything we wish in some expressions. And the two expressions that we're going to deal with in the first few chapters, and of course we're going to talk about domains of these square root functions and these what we call rational functions. The square root function, and this is called the rational function because it's a ratio. Actually, the 1 over x specifically is called the reciprocal function, but it is a rational function. The thing is, we can't plug in anything we wish in them. So you can take your calculators and test it if you don't believe me, but we cannot plug in negative numbers inside a square root. So anytime you plug in a negative number inside a square root, and I can show you as I do have our calculator here. So if I put the square root and I put a negative 1 inside, it says no real answer immediately, right? Fine, put in negative 5, same thing. Any negative value that you plug in, it's not going to produce a real answer. So therefore, it cannot be part of the domain. So in other words, the domain of this function is only positive real numbers and that's too much to say. By the way, you can't put in the square root of 0. The square root of 0 does exist because again, the square root of 0 means what? What number multiplied to itself? is equal to 0, well, the number that multiplied to itself equals 0 is 0, right? So that's fine. So the way we would write this, instead of, oh, I can have 0 and everything possible, we're going to talk about interval notation by the end of the section. So we're going to say, from the number line, I start at 0 and I get all the way to positive infinity. So think about this. We talked about the number line, yes? We talked here is 0, and then here are all the positives to the right. And so the number line stretches from negative infinity to positive infinity. So what we want to do is we want to choose 0 and the positive side. So we're going to say I'm going to start at 0 and go all the way to infinity. Okay. So be careful anytime you have square root functions, because you can plug in anything you wish in them. Okay. Same thing with fractions. We already talked about this in the review chapter. The one thing you are not allowed to plug in for x is the number 0. So you cannot divide by 0. 1 divided by 0 is undefined, and we talked about it. So this is going to come up many times. Division by 0 is not possible. Here, ask your calculator if you don't believe me. 1 divided by 0 can divide by 0, okay? So not possible, okay? So therefore, the domain of this function is anything, and I can write this several ways. So I'm going to say the domain is all the possible x's such that, so this bar here is read as such that x does not equal to 0. Or another way of writing this in interval notation is that I'm going to go from negative infinity up to 0. And then again from 0 to infinity. So anytime we put a parentheses means 0 is not included. So both ways are okay to write. You can just simply say x cannot be 0, fine, that means everything else. Or you simply skip over 0 and you put an open parenthesis. So might as well actually just go here at the end of the section and talk about interval notation right away because it is important. So let's say our set indicates I want all the numbers up to some kind of value b, and that value b is included. So here, let me show you what this might look on the graph. So I want to include all the numbers up to some kind of number b, up to, right? So everything up to some kind of number b, but b is included. So when you include b, you can put a bracket there, or you can bubble it in. Both ways work. But remember, every number line stretches from negative infinity to positive infinity. So the numbers in questions are anything starting at negative infinity up to b. So anytime you say including, you have to use a bracket. Okay, including, you use a bracket. Now let's say I want the numbers from a up to a b, but a is included and b is not. So include, put a bracket. Not include means you put a parentheses. So here, including means you put a bracket. Don't include means you put a parentheses. Same thing here. If you, let's say, do the same thing, but you exclude a, but include b. So a is not part of it, but b is. Then anything that's included, again, you put a bracket, okay? When you include both, you put a bracket of both. Okay. And so let's say numbers less than a or greater than b, for example, means what? So you're going up to A, and then again from B, less than A, so to the left of A, and greater than B, so to the right of B, and none of them are included, so those endpoints are not included. That's why we put parentheses. So all real numbers, remember, we put an R, means anything from negative infinity to positive infinity. So let's practice this a little bit. So let's say I'm going to say I want all the numbers greater than or equal to 6. Well, here is 6. Greater than 6 means to the right. And it says or equal, that means I'm including 6. So the interval notation for this, which is something that we will use a lot, interval notation, is from 6 to infinity. Let's say I want to say I'm including all the numbers less than 2. Okay, on the number line, here is somewhere 2. Less than 2 means lesser values than 2. And as you see, it doesn't say or equal, so I'm not including 2. So therefore I'm going less than, so from negative infinity up to 2, but 2 is not included. So it doesn't equal to 2. That means we are stopping short of 2, so we put a parentheses. Let's try the one that we had. I do not want 0. That means what? Here is 0, and I have to exclude 0. That means what? I'm looking at all the numbers up to 0, 0 not included, and all the numbers after 0, same thing, 0 not included. So because I'm not including 0 on either end, I have to put a parentheses at both those ends. Okay, so that's how we deal with interval notation. And now hopefully as you have a little bit of a better idea, let's go back here. Okay. Find the domain. So again, the only restrictions for now is whenever we're dealing with square root and rational functions. And don't worry, we're actually going to be looking at the little, I just kept it very simple for you. For now, they're going to become a little bit more complicating, square root functions and rational functions, whenever we actually deal with this function specifically. But by then, we will have practiced on these expressions quite a bit. So, as you see, you're dividing by a fraction. So x minus 3 better not equal to 0. So what's going to make x minus 3 equal a 0? Well, if x is 3, right? 3 minus 3 would get you a 0 on the bottom. So here we're going to say that the domain, as I said, you can use both notations, is all the x values such that, so this bar is read as such that x does not equal to 3, or you can write, I'm going to go from negative infinity up to 3, and then again from 3 to infinity. And I'm not including the 3 on either end. I want x minus 3, so this quantity here has to be more than 0. Okay, so what must happen for the answer to be more than 0? Well, it means that x itself has to be more than 3, right? So if you take a number more than 3 and you subtract 3 from it, you're going to get something positive, right? But remember, you can have 0 inside a square root, so therefore x can also equal to 3. So therefore, the domain of this function is anything 3 or more, where 3 is included. Okay, so we're using this. You can also write it in we call this set builder notation. But since we're going to be using intervals so much, the interval notation is preferable. But you can write both for now. All right, here's another one. As you see, There are no restrictions on this function. There are no square roots. There are no fractions with x's on the bottom. So the domain for both these functions is all real numbers. Any real number you plug in here for x is going to produce a real answer. Any real number times 3, subtract 2 is going to produce a real answer. So no problems here. The only problems we have are with fractions where x could become 0 in the denominator, or where the denominator could become 0. We can't have that. Or square roots where the quantity inside could become negative. So again, we don't want that. Okay. Reading the domain and the range off a graph. These are very good questions. So here it is. This is a function. It passes the vertical line test. I'm going to write D for domain so that I don't write so much. Now, the domain is all the possible x values. So what do? I simply look up to the x-axis and see which piece is covered by this graph. But which piece is covered by this graph, as in looking left and right alongside the x-axis. So as you see, and the end are bubbled, means it's not going to go on forever. So the x values covered by this graph go from -6 up to +3. That's it. This graph has been bubbled in at the ends. In other words, here, I'm just going to make sure you guys see what was there. In other words, the graph does not go on forever, right? It starts exactly at -6. It goes up to 3. Now, when you look at the range, so I'm going to write R for the range. Again, you can, even if I turn my iPad sideways, you're not going to see other than the screen, but you should try and turn your head sideways or so. The range is the y values, right? So I have to look back to the y-axis, okay? That's the range. So what kind of y values are covered? So again, it's bubbled in, -6 up to -4. That's all I have covered by this graph. And unfortunately, this stretched a little too much. Maybe I should turn my iPad sideways. Nope, it doesn't want to do it. I don't want to color too much, but fine. Right. So it is very important when you write a interval that you go from smallest to largest values. We never go large to small, but small to large. So on the number line, it's easy because you look at it from left to right. On the number line for x, so on the x-axis, on the y-axis, you have to go from bottom to top, right? As we go from negatives to 0 to positive. So smallest to largest value. Let's try this again. Now, what you see here could be tricky, but do you see the arrow here? That means this graph is going to keep going the same way further and further. So it doesn't stop there. And if it helps you, you should continue it so that you could see that this graph goes on and on. So the domain, again, I'll write D, I just said, is going to be anything that's covered by this graph alongside the x-axis. So as you see, this is going to go on forever. So the domain on the negative side, so the domain is -infinity up to 4. And as you see, this endpoint here is bubbled in. That means it stops exactly, and it includes the 4. It is a little trickier to read the range because you might want to stop right here, but no, the range, again, set this on its side. How high up does this graph go? This graph goes down, 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 but really no higher than what? This point right here. So the highest point on the graph, as you see, is 3. So the range is all the way from negative infinity up to a highest point of 3. So that's the highest this graph is going to go. So there's nothing up here above 3, right, that you see graph on. And there's nothing to the right of 4. So it's no more than 4 on the x-axis and no more than 3 on the y-axis. Now, this graph right here stops with 2 choices, a bubbled in point and a bubbled out point. So that means this point here is not included and this point here is. So when I'm looking for the domain, is going to be -3 not included because that point wasn't bubbled in, up to 2 included, so I put a bracket. The range means the y values, so it's -6, and that seems to be included because the point here definitely hit that line where y is -6. And the highest point is 5, and that's included as well because we bubble in that point. Okay. So put the graph on its side and look at lowest possible y value to highest possible y value. Okay, that's the range. Okay, and here one more. This one's pretty easy because this graph surely it's gonna go all the way. This graph surely gonna go all the way. There's no stopping. So the domain is, this arrow will stretch slowly but surely all the way left, all the way right. So you can write -infinity to +infinity. The range is, again, this goes all the way down and all the way up. So the range is also -infinity to infinity. So again, you have to say, does this graph stop and go no higher than, right? Or does this graph stop and goes no lower than? And if it keeps going higher and higher and lower, then it goes all the way to +infinity and -infinity. Right, so that's how we read graphs. The interval notation is important, not just for this section, but for many to come. So again, if a point is included, it's bubbled in, means we include the end, we put a bracket. If a point is not included, so we go almost as close as possible to a value, but that end point is not included. We have an open circle. Then we put a parentheses on the interval.